everyone, myself Dr. P. Ashok Babu, working as Professor and Head EC Department. So in this video, I am going to discuss about some problems in transmission lines. So the problems based on a reflection coefficient and VSWR using Smith chart. So the first problem is a lossless transmission line with Z0 equal to with characteristic impedance Z0 equal to 50 ohms is 30 meters long and operates at 2 megahertz frequency. The line is terminated with a load of ZL equal to 60 plus J40. If V is equal to 0.6 C on the line, then we need to find the K value. K is the reflection coefficient. S value is VSWR. Then we need to find out the input impedance using the Smith chart. So here to find the reflection coefficient, VSWR and input impedance from the Smith chart. So here we need to find the normalized impedance value. So here we have given ZL equal to 60 plus J40 and the length of the transmission line L equal to 30 meters and frequency F equal to 2 megahertz. Voltage V, velocity V equal to 0.6 C. 0.6 C, so where C is the velocity of light. Therefore, Z0 equal to 50 ohms. Then we need to find the step 1. We need to find the normalized impedance value. So the normalized impedance value is nothing but ZL by Z0. ZL by Z0 will give the normalized impedance value. Therefore, 60 plus J40 by 50, which is nothing but 1.2 plus J0.8. 1.2 plus J0.8 ohms. So here, by using the Smith chart, here we need to represent the 1.2 plus J0.8, where 1.2 represents the R circles and 0.8 represents the X circles or reactance circles. So on the graph, we need to represent as 1.2 in R circles and 0.8 in X circles on the X circles. Before once you check the graph, so it is in graph. So the point P, it is the origin. Origin is the 10 circle. The radius of 10 circle is a 10 circle. So at this point on x-axis we have the origin. So here we need to mark that 1.2, 0.8. 1.2 is a resistance circle and 0.8 is a reactance circle. So here this point is 1.2, 0.8. So here circles are, these are the resistance circles and these are the reactance circles. So here just mark 1.2, 0.8. So assume the point as P. Let OP as radius. Draw a circle. Let OP as radius. Draw a circle. So here the circle touches the x-axis on right hand side at point S. So this point S represents the VSWR, voltage standing wave ratio. Next. So assume that point as point P as 1.2, 0.8. So from origin to point P, measure a distance. Draw a circle from origin with OP as radius. Then that circle touches the horizontal axis. At that point represents the VSWR. Therefore, the circle touches the horizontal axis on right hand side at 2.1. Therefore, S equal to 2.1. Where S is nothing but the VSWR. Next, we will find the reflection coefficient. To find the reflection coefficient in polar form, we have the formula. Reflection coefficient equal to magnitude of the reflection coefficient with some angle. So extend OP to outer rim. So here from the graph, extend the same line OP to outer rim. So here this line touches the outer rim at theta equal to 56 degrees. Now we need to find the magnitude of reflection coefficient. So here we can find the magnitude of the reflection coefficient. So first we measure the OP distance. So here in the curve, you measure the distance from the curve. Measure the distance to find the magnitude. So here, so theta equal to 56 degrees. To find the magnitude of R coefficient, measure the OP length. Now on the bottom chart, we have the R coefficient scale is there. So let us assume the OP distance of 10 centimeters. So on R coefficient scale, measure the distance. So that will give us the magnitude of the reflection coefficient. In another way, we can find the magnitude of the reflection coefficient. So here the angle theta is equal to angle 56 degrees. We need to find out the magnitude. To find the magnitude, Here the ratio of OP by OQ will use the magnitude. So you can find the magnitude in two ways. The first method is, so by measuring the distance OP, so on R circle scale, we can measure the same distance that will give us the magnitude of the reflection coefficient. And another way, we can find the magnitude. So here the ratio of OP by OQ will use the magnitude of the reflection coefficient. So here the reflection coefficient, magnitude of the reflection coefficient is 0.35. Therefore, the reflection coefficient is 0.35 with angle 56 degrees. So another way, that is OP by OQ will use the magnitude. Next, we need to find the input impedance. Next step is to find the input impedance. First, we'll find the lambda value. So you know that lambda equal to C by F. C is nothing but the Vp or Vp by F, or C is equal to, given velocity is given 0.6c by frequency F. So 0.6 into velocity of light is 3 into 10 power 8 by frequency is 2 megahertz. Therefore 2 into 10 power 6. So it is 90 meters. So therefore lambda is equal to 90 meters. But in our problem, the transmission line is given as 30 meters long. Therefore for 30 meters, how much the lambda? Therefore 30 into lambda by 90 meters will give the lambda value for 30 meters. Therefore for 30 meters, the lambda value is lambda by 3. Where lambda is nothing but in terms of degrees, it is 720 degrees. Lambda equal to 720 degrees. Therefore, lambda by 3 equal to 720 degrees by 3, it is 240 degrees. So, in terms of angle, 240 degrees. Now, therefore, we need to do an angular momentum of 240 degrees. So, we need to move towards the generator or toward the clockwise direction or away from the load in clockwise direction from point Q. So from point Q, so if we move towards the clockwise direction, so here with an angle of 240 degrees, so 240 degrees nothing but it is 180 plus 60 degrees, 180 plus 60 degrees. Then draw a line from O to that line, touches the S circle at 0.48, 0.3. So here if we move it 240 degrees, here if we move the 240 degrees, if we move the 240 degrees from Q, it touches the, it covers a 240 degrees. It is the, from this one, if we move 240 degrees, it will reach this point. Now extend a line from origin to that point. So here, this line will touches the circle at a point G. So now the coordinates of the point G are, it is 0.48, 0.03. 0.48, 0.03. 0.48, 0.03. Therefore, input impedance equal to 0.48 plus J 0.3. Then we need to find out the actual input impedance. Therefore, actual input impedance equal to normalized input impedance into Z0. Therefore, normalized input impedance is 50. Therefore, 50 into 0.48 plus J 0.3. Therefore, it is 23.5 plus J 1.5 ohms. So, this way we can find out the input impedance of a given problem by using the Smith chart. So, it is a method to find the, from the Smith chart, we can find the reflection coefficient, we can find the VSWR, it is nothing but the VSWR. So, here we can find the input impedance, Z input impedance. So, this way we can find the all the values by using the Smith chart. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.